So in this video we are going to study about ethanoic acid. Okay, about ethanol we have seen. So ethanoic acid, these reactions are important. So let us study about ethanoic acid and its four main reactions. Okay, four main reactions. So do you know the common name of ethanoic acid? Common name of ethanoic acid. So the common name of ethanoic acid is acetic acid. Okay, acetic acid. So the another one more word is there. It is popular, vinegar. Okay, so vinegar is what? 5 to 8% of ethanoic acid, ethanoic acid in water. Okay, so 5 to 8% of ethanoic acid in water is called vinegar. Okay, so just understand. So acetic acid is the common name for this ethanoic acid. Now let us talk about the physical properties. Okay, physical properties of ethanoic acid. Physical properties of ethanoic acid. So, yeah, when we are talking about physical properties, we can say about melting point. So, the melting point is around 290 Kelvin. Okay, so it's like 17 degrees Celsius. So, in 17 degrees Celsius, it will melt. So, if it is below 17 degree, it will freeze. Okay, so that is why mostly in winters, if the temperature is very low, this ethanoic acid will freeze. Okay, ethanoic acid will freeze, and when they freeze, it is very much like the ice or glaciers. Okay, so it is very much like the ice or glaciers. So it is also called, so that is why it is also called glacial acetic acid. Okay, since in cold temperature or winter, it is seems like ice. Okay, ice, the frozen ice, it is also called glacial acetic acid. So this question can be asked. Okay, so this question can be sometimes asked in your examination for like 1 mark. Why ethanoic acid is called glacial acetic acid? So you should be easily able to write. And one more physical property about this ethanoic acid is that it is much weak. It is a weak acid. Okay, you can write it is a weak acid. It is a weak acid. Weak acid means it is stronger than alcohol. For example, alcohol is a very weak acid. So we can write it is stronger than alcohol, stronger than alcohol, but weaker than HCl. Okay, hydrochloric acid. Hydrochloric acid. So we can write it like this. Okay, so these are the physical properties of ethanoic acid. So now let us look at the chemical properties of ethanoic acid. So in chemical properties means what? Chemical properties means the reactions. Okay, so here we will study about four type of reactions undergoing by ethanoic acid. So the very first one, reaction of ethanoic acid with sodium or metal. Okay, so this is the first one. So are you remembering, are you remembering the uh, general reaction, okay, of acid plus metal that you have studied in the second chapter? Acid plus metal. So if you remember, what you will get is you will get salt plus H2. H2 means what? Hydrogen. Okay, so this is a general reaction. Okay, so now what is the acid here? See, ours is also an acid, ethanoic acid. So what is the formula of ethanoic acid? So write the formula. Yeah, it is CH3COOH. So we will have CH3COOH plus metal we are taking sodium. So what you will get? You will get, see here the high H, okay, this H will form this H2, okay, and this Na plus will be attracted by this CH3COO minus ion. So that is how the salt is formed, because always salt is a ionic compound of an anion and a cation. So this is the cation and this is the anion. Okay, negatively charged ions are anion, positively charged ions are cations. So what will happen is CH3COO Na will be formed. This is the salt and this is hydrogen. So this is our first reaction. So what is the name of this salt? This salt is sodium acetate or sodium ethanoate. Okay, we can write sodium acetate. Okay, so that's the name of this salt. So that's the first reaction. Now the second reaction is also very easy. The second reaction is reaction of ethanoic acid with a base. So always ethanoic acid, we know it's an acid. Okay, base we can take NaOH. Okay, example. So acid plus base, what will be the product? These are called neutralization reactions. Neutralization. So always neutralization reactions will give salt plus water. Okay, don't forget. So this is the general reaction. Acid plus base giving salt plus water. Okay. So now let us write the reaction ethanoic acid. So our acid is ethanoic acid, CH3COOH plus base, let us take NaOH. See, one thing we are very much sure, water will be formed. Okay, so that basically that water is formed by this OH and this H. Okay, so H2O is formed. So basically, so what will be remaining? CH3. So I'll write it here. So the remaining will be CH3COO minus, and because from this and from this Na plus ion will be there. So this is going to form the salt, the same salt that is formed above. Okay, CH3COO Na, sodium acetate. So this is the second reaction. So what is the difference? See, look at the difference. Just the only here it was, see, one second, here it was hydrogen, okay, and here it is water. Okay, because earlier we took only Na and here we took NaOH, that is why. Okay, so just write this reaction to your notebook. Okay, now we can move on to the third reaction. So third reaction is also very easy. That is the reaction of acid with metal carbonate or metal bicarbonate. Okay, metal carbonate or metal bicarbonate. So this also we have studied in our second chapter. So the general reaction is like acid plus MC. MC is a short form of metal carbonate or metal bicarbonate. Do you remember what will be the products? See, the products is, okay, you can predict it is salt plus water plus CO2. Okay, so here also we will take the example. It's very easy. So first one is CH3COOH. What is that? Ethanoic acid. So let us take a metal carbonate. So we can take sodium carbonate. Okay, Na2CO3. Only this example you need to study because only this is given in your NCERT. Okay, Na2CO3, and we can also take a bicarbonate. Okay, NaHCO3. Okay, now what will be the products? See, what two things are very much sure. You can blindly write it H2O plus CO2 because that is given in our general reaction. Only the salt you need to confirm. What will be the salt? Salt will be the same salt that is formed above. Okay, which is CH3COONA. Here also it will be CH3COONA. You only have to balance it. Okay, so here there is 2 sodium, so you have to write a 2 here, then you have to write a 2 here, and it is balanced. Okay, the below one is already balanced. So this is the three reactions. Okay, we have studied three reactions. So basically this is an extension from the second chapter, don't forget that also. Now the very last reaction is, this is a new one. This is called esterification reaction. Esterification. So by the term itself, you need to identify that these reactions will create something called esters. Now the question is, what are esters? So you need to understand, esters are a sweet smelling substance. So it has got a very pleasant smell, a sweet fruity smell we can say. And the general formula is RCOO dash. Okay, that is general formula. That means this is carbon, this is oxygen, this is oxygen. This R means alkyl group. Okay, alkyl group. So alkyl group means groups like CH3, C2H5. Okay, so these groups are called alkyl groups. So here it is R, this is R dash. So R dash, this dash is because sometimes this ester will have two different type of alkyl groups, because all these are called alkyl groups. Okay, so that is why. So this is the general formula. Okay, these are esters. So reactions in which, so esterification is a type of reaction in which an alcohol, okay, alcohol react with acetic acid. So alcohol and acetic acid, alcohol plus acetic acid, okay, it will give an ester. Okay, ester plus water. What you need is, you need to take concentrated H2SO4. Okay, so this is the only condition. Alcohol plus acetic acid will give you ester plus water. So I will write the definition here for esterification reaction. So when ethanol, okay, ethanol is an example of an alcohol, okay, reacts with acetic acid, a carboxylic acid. So this acetic acid is an example. So instead of this, we can write carboxylic acid. That will be better. Okay, alcohol and carboxylic acid, two functional groups. So when they react in the presence of an acid catalyst, so this is an acid catalyst, a fruit smelling liquid, okay, like called ester is formed. This reaction is called esterification reaction. So let us write this reaction. An alcohol, let us take ethanol. Okay, so ethanol, what is the formula of ethanol? CH3CH2OH plus, let us take carboxylic acid. Okay, let us take a carboxylic acid. So let us take acetic acid, CH3COOH. Okay, so we need to find out what will form. So for easiness, what I am doing is, I am going to, okay, flip this molecule. Okay, I will write this ethanoic acid like this, and I will write HOCH2CH3. So here I have just flipped the side. Okay, so this is for easiness. So you need to understand. So water molecule will be eliminated. Okay, water is formed because we are taking concentrated H2SO4. This is a dehydrating agent. Dehydrating agent means it will remove water from the compounds. Okay, so this is a dehydrating agent. So basically what will happen is, this HO and this H will form H2O and the rest will combine. Okay, so one second. So this portion and this portion will combine. So what will happen? So what will happen is, the product will be, so we can write, first we can write this CH3COO. Okay, then write this CH2 CH2 CH3. This will be formed. Okay, so this is an alkyl group. So R, C double O, C double O. This is also an alkyl group. So R dash. So our general formula of ester is satisfied. Okay. Okay. So this ester, the name of this ester is, so remember it, ethyl acetate. Okay, that's the name of this ester. Okay. So this is the reaction. Okay, ethanol plus acetic acid will give you this CH3 C double O C2 CH2 CH3 plus water. This is esterification reaction. Okay, so there is also one more reaction associated with it. This ester that is formed. Okay, so what is ester formed? This ester. Okay, one more thing that you need to study along with this is that, okay, so this is the ester formed. Okay, so if you treat this ester with, so if you treat this ester CH3 C double O C CH2 CH3, if you treat this with NaOH, so you will get the salt that we have studied earlier, this salt. Okay, this salt. So we will get that salt CH3 C double O Na, plus we will get the alcohol CH3 CH2OH, because this Na will attack here and this OH will go with this. Okay, so basically, 1 second. So it will split like this. Okay, into two half, and OH will go with this to form this ethanol, and this Na will go here. Okay, Na will go here to form this salt. Okay, so this similar reaction is used in the preparation of soap. Okay, so in soap basically it is ester plus NaOH. Okay, that will give soap plus an alcohol. Okay, so this is not a this is not a soap, but these type of similar reactions are used in the preparation of soap. So this reaction is also called saponification reaction. Okay, so these type of reactions in which ester and NaOH, okay, reacting to form soap plus alcohol is called saponification reaction. So this reaction, okay, this reaction, so I will erase these things. So this reaction you can write as an example for saponification reaction. Okay, so this reaction you can write. Okay, so in NCERT, this, if you are writing this example, okay, I mean this one, if you are writing this as an example of saponification reaction also, you will get mark. Okay, so these are the important things that you need to remember and study from ethanoic acid. So if you have any doubt, you can comment in this video. Okay, so any doubt you can comment below, I will reply. Okay, thank you. So look at the video.